Hello. Uh, Okay, good morning, everyone. Welcoming to our webinar today. Okay, good morning, everyone. Thank you for joining us in the International Scientific Webinars 2026. My name is Ui Pekin, and I'm a science officer in the biochemistry at Hospital Sultan Bahia, Alostar. I will be serving you as your moderator for today's sessions. Today, we will be hearing a presentation titled Anthropogenic Oceanography and Emerging Pollutions in Marine Ecosystems. Before we begin, I would like to take a few minutes to introduce our distinguished speaker, Associate Professor Dr. Muhammad Fuad Miskon, is from the International Islamic University Malaysia Kuantan campus. Dr. Fuad is a specialist in the marine pollutions, aquatic impacts assessments, and the anthropogenic oceanography. He has an extensive experience in environmental impacts assessments and marine conservation. Dr. Fuad's research seeks at the critical intersections of human activities and the marine health, focusing specifically on the biomonitoring of microplastic, heavy metals, and rare earth elements within our marine ecosystem and its impacts towards the humans. Through his extensive field works and research along the Malaysian coast, he, he is actively mapping the physical and the chemical impacts of the modern industrializations on our marine ecosystems. He is currently the head of the Department of the Marine Science at IIUM and has been actively involved in international collaborations like Oceanography, including the projects under the International Atomic Energy Agency Malaysia. He also previously led the Institute of Oceanography and Maritime Studies, IIUMs, from the 2018 to 2023, with an impressive portfolio of the publications on awards, according the Best Academic Award at the IIUM. We are truly honored to have him with us today. Ladies and gentlemen, please join me in the welcoming the Associate Prof. Dr. Muhammad Fuad Miskon. Welcome, Prof.
All right, thank you so much, Madam Oi. Bismillahirrahmanirrahim. Again, thank you for the introductions. And I think I will not talk much about myself because it's already been introduced by Madam Oi. Okay, I will be straightforward in my slide. Okay, for today, I'm going to share some of my experience, some of the data that I got, and some of my journey towards that. I mean, it's like for today, it's not just theoretical things because I'm a person of that. If I have the theoretical knowledge there, if possible, I want to prove that. I mean, like we talk about emergent pollution. So when I thinking about, is there any pollution there? So I'm going to put some research element there, take sample and everything. Okay, all right. I forgot. Sorry to say. Thank you so much, PPSM, for inviting me on today's event. Right. Okay. Mm, okay. So I'm sharing a bit of what I'm do in my daily life. So currently I'm a lecturer and also a researcher at IIUM. So I would say like I have been several level in my daily work. For example, as a teacher or lecturer, I'm also giving a lecture to the undergrad and supervision to postgrad. But instead of that, some of the data I used to give to community as well, because as you can see there, I'm also a diver. I'm also a, a user of some documentation and some of software and related with research. And I also as one of the subject specialists under Department of Environment Malaysia and trainer for some workshop also. So from all of that, the data, the research that I have done, so I was thinking that why we cannot simplify this particular research data into something that a student, a citizen, a coastal community can digest that particular data. So I just translate that into a layman idea. Oh, sorry. Is there okay? Is there somebody raise your hand? Because I'm in a full slide right now. But you can interrupt me at any time. Okay, no problem on my side. Okay, all right. Okay, and then instead of giving to school children, I also have engagements with some company and some institutions that want to do some CSR. So like for these pictures, we just have a mangrove planting event, but during mangrove planting event, we adjust to make it water quality recovery event, and some about plastic, how this using this particular mangrove planting to trap some plastic that used to be as a recovery for that particular area that have a very garbage, lots of garbage. Okay. And this is some of my picture that I engage with international collaborations. This one is Ocean X, and also they have been in our area at 2024 for like 3 weeks. So me and some friends at UMT have participated in this particular event. So basically, that is my life. This is my daily life that I'm going to share some of data input that I from all these tasks to everyone. Okay, so basically this is Malaysia. This is we are here. As you can see there, that we are surrounded by the oceans. We are surrounded by the oceans. We are actually a maritime country, which means that every part of our states, of our country, actually is surrounded by the oceans. Of course, it's not like every part of that. Even for Sarawak, this area is not exactly exposed to the sea. Okay, oh sorry. But still, we have lots of like here is Strait of Malacca, and this one is South China Sea, and then this one was Laut Sulu, and which mean that we have a very large area. You can see that we have a very large area in our Malaysian. Hence, this makes that the ocean itself actually is quite sensitive area, because we exposed with lots of ocean area. So any change to that coastal populations in here will affect the oceans. And because of ocean is a connecting connecting of from one ocean to another oceans, to one sea to another sea. So any particular change to this particular, for example, Kota Baru, it might as well will affect the Johor Bahru also. Okay, so I stay here, my research and everything in IUM Kuantan here. Okay, maybe I just add some info that IUM you might see in Gombak only, but that is the main campus. So IUM have another two campuses. The big one for the undergrad First is Kuantan, I am Kuantan, which is currently my office right now. So in Kuantan, we are very focusing right now, my faculty or my kuliah, uh, very focusing on science, natural science. And my departments also very focused on our marine science area. Okay. And another one is at Pagoh campus. The one I think is on tourism and management. All right. Okay. So maybe some of you is questioning what is this anthropogenic oceanography? What is the definition? Okay, I give you a very brief one. Okay, anthropogenic means that something that out of from the natural one. That is anthropogenic. And oceanography is if you cut off is ocean. The graphy is the one meant science of the oceans. Okay, so the definition of anthropogenic oceanography as whole is the study of how human activities alter ocean system processes and the interaction across physical, chemical, biological, and socio-economic dimensions. Which mean that if you read this here, that it has interaction between the natural one to with human activities, which we are. So there is a relationship between you. Maybe some of you thinking ocean is just ocean. Huh? Why is the relationship with Malaysia with human? So this is the interlink between both of them. Okay. Okay. So I have started my study in the degree. I started in degree in marine science because my degree is on marine science. So I have been studying about the oceans, take the data of the oceans, start from my undergrad until I am currently now. Yeah. From every data that I used to have, we have a very dynamic. It's not exactly like, for example, the temperature of this will be, I think temperature is a very physical one. Okay, let's say water quality for nitrate, for phosphorus data is very different from places to places. And also when you came, when you came another year, next 2 year, next 3 year, so actually the data has been quite different. It's whether it's not exactly decreasing, but we will very prone to have the increasing data. So why is that? Why is that? Which means that when you have a very data dynamic, very dynamic, and the data is actually is something that is not for the natural one. So we may be thinking that it's anthropogenic. It's maybe comes from the anthropogenic sources. Okay, so the ocean remains natural in origin, but it is increasingly human modified in process, exposure, and response. If you talk about salinity, yes, salinity is very dynamic. No, salinity is very constant from the millions years ago after the exact salinity process happened. So it's around, at ocean, usually salinity is around 35 to 37, 35, usually 35, 33, 35, something like that. Okay. If there were a heavy rain or during monsoon season, the salinity might be a drop a bit because of the introductions of fresh water from the rain. Or at estuary area, muara, and muara area is a brackish salinity, which means that they have decreasing salinity because of introduction fresh water from the river. Okay, that is. But something like phosphate, nitrate, nitrite, uh, ammonia, heavy metal like lead, cadmium, zinc, etc., etc. Rare earth elements. Rare earth element is lanthanide. I mean, if you can see in the periodic table, see the lanthanide from the lanthanum until lutetium. That is a rare earth element. After this, we're going to inside that. Okay, so as the first one, it's a natural process. Usually, it's a natural process. The data should be a bit constant. It will be a dynamic because of current and because of wind and everything to make wave. It will dynamic, but it will almost most constant. We have the data of like years of decades of data. All right, but then after sorry, after we keep on take the data, even you can have the data from another study around the world, from a literature review, or maybe you can ask from that particular researcher. So the current one, the current reality is that it has been prone to by climate stress, by human pressure, urbanizations, land use change, infrastructure, habitat loss. habitat loss, and also, uh, and why is that? Why is that? And because of human modified processes, human exposure, and biological response. So this is something that if you touch something like that, it will automatically or naturally it will change, of course. But as we talk about sustainability of the elements, because as a human, sometimes we really need that to use that particular area. For example, you talk about habitat loss or urbanizations. Okay, we need home, we need some facilities of building and everything. But before we do that, we need to ask: is it we need purely need, or we just add up to need that? That's something sustainability, because in the ecosystem of the earth, we are really interconnected with each other. Everything, there's almost everything connected. Okay, so right now, the system right now, I give a very roughly outcomes, drivers, and pollutant groups. Right now, my pollutants group, I put on microplastic, heavy metals, rare earth elements, and some data on water quality, but I'm not putting here because this is actually my focus. You can have lots of pollutant groups more. You can have lots emerging, such as from pharmacy, from everything. It also has their own pollutant group. Even I talk about microplastic. When you talk about microplastic right now, the research is getting towards nanoplastic. And then when the nanoplastic has become bigger, I think it will be picoplastic and everything. So the pollutant group is very various. All right. Okay, so what is the driver? The driver is built would mean from urbanization, residential, tourism, rejuvenation, coastal development. These are some of the drivers. Okay. I'm not talking about blame all these drivers. No, these are the driver, which mean that we know this and how we want to handle that. Okay, the outcome, what is the outcome? So it will be altered transport, will be biodiversity of the food, and then biological uptake and ecosystem stress. And some of us might be, it's okay lah. I think they are not harming us. The thing is that the food and health risks, because we used to eat from the environments. If we talk about oceans, what do you eat from oceans? Fish, cuttlefish, squid, prawn, crab, and lots of things, bivalve, shellfish, and everything. So when they were exposed to these pollutant groups, so we can expose to. Now, because like heavy metals, we have some in Malaysia, we have regulations on that. There are some limitation of how this mercury, how this arsenic, what else, cadmium can penetrate into this particular fish, for example. Okay, all right. And then microplastic, it has been confirmed that it has penetrated lots of levels from the water, from the sediment, from fish, and even we talk about microplastic in the air, microplastic in the honey, we got microplastic in the carrot, lots of things. And then because it has long uh, confirmations of health effect, so it's still much in the research. Microplastic has been found in the placenta, in the mother's breast milk. Okay, right. So we can have lots of things about microplastic is emerging right now. Okay, and then rare earth elements. Rare earth elements for this. I think I go to the slide. I think everyone watch better for this one, like rare earth elements. Okay. All right. So this is actually the physical driver. We isolate the anthropogenic signal in coastal vulnerability. The coastal will be vulnerable by several drivers. We have a physical driver, which means that wind, so current, monsoon season, and etc. etc. This also a driver. It's a natural one. It's a natural one. Of course, somebody will ask about climate change, everything. Yes, we have some data about that. So it also contributed this part as a driver. And then we have the CVI risk, which means that CVI risk any particular changing in the coastal area will affect nature as an anthropogenic stresses to the CVI. It's a coastal vulnerability index. If you have a very high coastal vulnerability index, means that the area that coastal, the erosion, everything will be very high percentage to vulnerable. Okay, and then socioeconomic driver. This if you talk about very direct, I think some of the fishes, cage fishes, or at Tumpat Kelantan has been exposed to harmful algal bloom. And these harmful algal blooms can make people die. Okay, we have the cases also at the Tumpat and then at the Kuantan Port. And if I'm not mistaken, last year or last 2 years, we have issue at Kuala Linggi. Kuala Linggi. It's harmful algal bloom is not. We still in AI predictions. The research right now is currently doing some predictions on when will harmful algal bloom, because it's a standard natural process. But the exact harmful algal bloom will be a very specific species. Okay, all right. Okay, so these are some of the multipollutant of this particular that I said microplastic, heavy metals, and rare earth elements. So usually the source from microplastic usually from island tourism and waste, which mean that when I went to island, I go to some islands in Malaysia. I have went lots, usually in area of Pantai Timur, from Perhentian, Redang, Bidong, Tenggol, Kapas, what else? Tioman, Sibu, and some more. Okay, if you go to islands that is a very far from the ocean, very far from the humans, and it's a scarce area. Okay, it's a very remote area, but you still can find plastic issue. You still can find plastic issue because, like I said before, ocean is a interconnection system. If you just throw out plastic bottle at maybe Kelantan area, you will find that particular bottle at even at Singapore, even at Tioman and everything. All right. Okay, so and then heavy metals usually from plastic from the industrial toxicant. If you have like a factory in particular river, and when they actually expose or dispose their waste into the river, we can have the exact data actually from the particular or rare earth elements technology industry signature. Rare earth elements is a lanthanide that is used for right now. The most popular thing is the EV, electric vehicle. The battery and the components and particular body build is from rare earth elements. That's why during I think everyone knows about Linus, right? About Linus is from Australia and Malaysia. Some of collaborations to make Malaysia is one of the top processor for this particular earth elements, because from the predictions that it will over the top for the economy. It's a very economy boost because Australia have lots, China have lots, America also has a RE. So they like compete each other, but we can process them to make sure we can have some economy from that. Okay, all right. Okay, I go to the next slide better. Okay, I'm going to share some of the findings from my current research. Okay, I will share about three elements, which is on the heavy metals, on the rare earth, and also on the microplastic. Okay, all right. You can find this my current research from my ResearchGate, or I think ResearchGate. I put lots of this research and my ResearchGate. If anyone didn't know about ResearchGate, usually it's a researcher always share some publications, our publication in that ResearchGate, so that it will attract like any networking or any collaborations from international area. Okay, it's a ResearchGate, just ResearchGate, pintu pagar, ResearchGate. All right. Okay, so I used to love using bioindicator, which mean that bioindicator is using some of biological organism. Like right now, I'm showing you the Sarcus traculata is an oyster. It's a raw oyster. Because why? When I first doing indicator, I like to have a bioindicator of raw oyster because we have lots of around this peninsula area. We have lots of rocky shore. And rocky shore prone to have a rocky oyster, rock oyster. So I want a data that can represent whole Peninsula Malaysia at that particular time, which means that within 2 weeks, I need to sampling. This is during my PhD. I used to sampling every part of Peninsula Malaysia where accessible, because some of area like in Ipoh and some area at Selangor didn't have any rocky shore area because the erosion issue. Some here cannot penetrate, cannot be accessible. Okay, so within 2 weeks we got the data of bioindicator during times, so I can get the data that really reflects. We can like say West Coast or East Coast, it's much more polluted. It's much more polluted during that time. That's the question. Okay. Okay. So bioindicator, which mean that if you have pollutant or pollutions in that area, let's say during that time I at East Johor, at Johor Timur area, as whether Mersing or Sedili or Tanjung Balau, Pengerang, and what else? Another one I forgot. But the one Batulaya, if I'm not mistaken. Okay, so when if that particular waters is polluted by heavy metal or polluted by microplastic, even polluted by rare elements, we can get the data. Uh, you can have a very exact data if you sampling on waters. But my questions, my research question is during time, what is the impact towards Earth? What is impact towards Earth? So I use a bioindicator first. I mean, like the rocky shore, the rock oyster is always been exposed to the seawater on that time. Seawater, which means that they bioaccumulate, they accumulate all the waters, accumulate all the sediment of a very tiny one. So it accumulate over time. So you can have the data. We have some, either you using carbonating to make sure the health of the oyster, or you can use some of the formula to just approximately what is its age. Because if age is like 1 year, so which means that 1 year has been exposed to the waters. That's a good of the bioindicator, because bioindicator it will accumulate over time. You can have the data, not the exact data, but historically, like 6 months before, 7 months before, which means that the particular data from the waters have penetrate into bioindicator. Okay, all right. So if you use water, of course, you can have the data exactly. But at area of rocky shore, it's very dynamic. The moment it splash, the wave splash the rocky shore area, and then if you come back, the data might be different from minute to minute. So you need to have lots of data. So I like, oh, okay, I don't want to this. So I rather give lots of efforts in collecting the bioindicator. Okay, all right. During that time, actually, I found that in East Coast Johor during that time is 2000, um, 2015, if I'm not mistaken. It's around that, 2015. Okay, we have a quite elevated data of zinc and copper during that time. So I just say that what probably caused that. We are not confirmed yet. We just have what is the probably drivers of that. All right. So it has a history. This, and then oyster also, I think lots of people eat oyster. Maybe not directly, maybe by cook, or maybe from the like oyster sauce and everything. Okay, so it has been consumed by human for many years, for decades. All right, that's why I choose for this one. And during that time, because rocky shore is everywhere in the peninsula, I choose the one also. Okay, all right. So this is rare earth elements. If you can see that in periodic table, you can have the from lanthanide, cerium, praseodymium, niobium, promethium, samarium, europium, gadolinium. Okay, this one is like rare earth elements, which means that like elements are much more available. The availability in the environment is much more higher. But the usage of heavy rare earth elements from terbium, dysprosium, erbium, thulium, ytterbium, and lutetium are much more high price. If I'm not mistaken, much more high price. So it used for semiconductor, EV battery, and lots of green technology, and also for military use. So during the data, using this, but again, particular of rock oyster, so I found that the West Coast area have enrichment of light over heavy rare earth elements in particular area. Uh, but for rare earth elements, it do not have any purposely limit yet. Like for rare earth, heavy metal, yes, we have. If I'm not mistaken, in the seafood product, mercury should not be 1 or 0.5 ppb uh, from the table 14. From the table 14, you should not exceed that. If you exceed that, which means that it exceed the permissible limit, you better not. Eat it. Okay, but this one thing. If you want to touch about fish or touch something that human eat, you are also touch for the. It's quite vulnerable because some fishes or some this also link with the industrial area with the industry and socio-economic. Like if I say that this ikan kembung has uh, very high heavy metal, so it will affect fishermen, right? So you have to. But right now, I found out heavy metals in fishes is quite okay. But there are some paper about the mercury. I think around 2000 something, 2000 something about the mercury. Okay, but that's one of the challenge of that. All right, one of the challenge of that. You need to play something strategically on that one. Okay. Right. So usually rare elements is something from the sediment from the soil. So which means that if you have the exact mechanism, exact pattern with the same with the soil, actually yes, that is a rare element. And because of we do not have the permissible limit yet, during my master, I used to have try to reflect the concentrations of heavy metals because we don't have the permissible limit yet. All right. Okay, so I'm sharing to you about microplastic. Okay, microplastic. So these are together with my final year project, uh, 2020, 2020. Okay, I I plan during the time I plan to use the boat A class by fishermen. Boat A class by fishermen. So my sampling site actually at Pasar Nelayan and Pasar Nelayan Pantai Sepat, Kempadang. It's at Kuantan area, in Kuantan area, this one. Okay. When you use boat A, okay, usually boat A class, they will go to the sea early in the morning. So they will come back this is around noon or around 12, 2 o'clock, 3 o'clock, which means that it shows that they will catch the fish only from this area because I want the data from this area. So if I have the data from LKM or because that one is from the boat C or boat B, that one is far from the Kuantan area. So I don't want that. So I pick up the boat A class. So I just wait here and then ask some questions where when that he went there. Okay. So the data that the fishes that we got, it reflects the area of Kuantan. Reflect the area of Kuantan. Okay. All right. Okay. So some of the fishes like Allah, sorry, like kembung or this one, when we do some microplastic detection, first we digest, we cut off all everything in the fish tissue and just leave the microplastic. And then we used to use for microscope to just separate them. If you use microscope, you might as well like see this one, you might see this as microplastic, but some of the sample actually is not microplastic. It's like a dead cell or something that not microplastic, maybe some rubber or something like that. Okay, so you need to confirm this particular microplastic using the FTIR. Right now, much more advanced is micro FTIR, or you can use also Raman or Raman. Okay, all right. So when during that time, because it's a final project, I used to FTIR. So we found that they also exposed to the PE, polyethylene, PT, polypropylene, polyvinyl, PT, PMP, and styrene. Okay, so it's confirmed that particular fishes that is at Pasar Nelayan has been exposed to microplastic. And microplastic actually is a vector right now. Okay, it's a vector. You can see that microplastic definition of microplastic is It's a plastic. It's either it's primary or secondary. Primary means that like needle, which means that we created by industry created that and some microplastic as it is. Uh, but primary, which means that you can have like plastic product has been exposed by UV or wave action if the product is on the oceans in the oceans, okay, in the ocean. So because of UV from the suns and then the wave actions, so later sooner or later they will turns out to be microplastic. Its definition microplastic is a plastic that 5 millimeter and below. Okay, and millimeter 5 millimeter and below. And microplastic is also a vector. Vector means that a transport like mosquito, a transport for JE, transport for dengue, okay, malaria, something like that. Microplastic, because of its physical, we talk about heavy metal and rare earth elements right now, right? It's a chemical pollutant. Microplastic is a physical pollutant, which means that it will become a vector, a virus, heavy metal, can attach or can like I said can attach with that particular microplastic. So when it has been consumed by the fishes, which we have found that when you consume that and you consume that, so it will be stay in our body. If they bring some virus or some heavy metals, we are also affected by that. That's why in the news or in the research, we have found microplastic in our body almost everywhere. And also, usually for microplastic, uh, we used to search microplastic in the GIT, in the gastrointestinal tract. So because microplastic will be consumed by their mouth and then it will be through to their GIT, their gastrointestinal tract. And you will find lots of microplastic there because it's very direct intake just by mouth and then it will be straightforward. But then for this one, I'm not talking about jit because people not eat perut ikan. We not think about the jit of the fish, right? You eat the flesh, the soft tissue. So we found that from the soft tissue also they got some microplastic. But it's not exactly as many. If you find that in the gid, you will find many. But in the flesh, you will find some in it, but we'll found that. Okay, confirming we found that. All right. So that is about microplastic. Okay, and then at the oyster, I found out also because, like I said before, I use this bioindicator oyster because it's almost everywhere. Okay, uh, we have found that the dominant particles detected were filament shaped and commonly black. Okay, which means that black plastic is always be found. Uh, and some of the plastic that some of the plastic you have color, right? Like even what example, top detergent, some blue, red, and purple, if I'm not mistaken. Okay, all right. Okay, so but when they has been exposed to UV and wave, some of them actually change the color. So lots of researchers also do some data about the color, but on my part, I was thinking about there might be changes from the first product until it become plastic. There might be some color changes, so I'm not put so much effort on that particular color. We go for the size, we go for the types, we go for the polymer, especially polymer because polymer has been used for cancer and health hazard index. This is my collaboration with Dr. Artika from Faculty Medicine. Okay, so but the microplastic that we have found, so we try to have the data only the methods only right now. The data of health index usually on monomer. Right now we only find polymer. Okay, so there's some adjustment on the calculation on that one. But if you can see right now, like Madam Oi has been mentioned before, I I use for biomonitoring, but then I relate that with human impact for any anthropogenic oceanography data. So I connect that with human impact, and then from that particular data, if we found it a concern, we try to have the solutions on that particular matter. Right? Okay. Uh, mm, okay. Uh, let's go to the next slide. Okay, this is bivalve. Bivalve, oyster is one of the bivalve. It's one bivalve. It's under category of mollusk. Like gastropod, you know about gastropod. Gastropod is snail. It has a shell. But for mollusk like oyster, it has shell, but it has hinge, which means that it can open and close. That is about mollusk. Okay, but both are under bivalve. Okay. Am I correct? Oh, sorry, because I'm not a biologist much. I think bivalve is the one that has him, and then gastropod and bivalve is under mollusk. If I'm not mistaken, I'm sorry if I wrong about this one. Okay. Usually this is the methodology. You can see that at the end, at the left side of my slide. So we go to sampling. Sampling is the most fun thing for me. I like that. I love that sampling. And then my sampling is always at oceans. You can have a blue ocean, seeing very release all the stress. But then after sampling, of course, the stress start. So you need to do some lab work and everything. But that is a job as the researcher here. I think most of you are from the as a sign officer and officer who use this lot of thing. Some sampling, some instruments, some data, and some uh, used to what else with quotations with PO, procurement, everything, right? Okay. So after that, physical measurements. So we go for drying and then digestions. Digestions mean that we want to get rid everything and just left the microplastic. Okay. And then I used to have flotations. Flotations mean that we need to try the floating microplastic because microplastic is very light. It's very light, which means that when you put water, it will float. It will float. But in the ocean, actually, the floating also differs some microplastic properties one to each other, because some of like PP, uh, like PP is quite dense. PVC is quite light, which means that if you put in the ocean water on the seawater, it will float at different level. It will float at different level. So that's why we have found microplastic at the seafloor also. So you see that from the if the depth is around 1 meter, I think it's very it will be very fast. Not very fast, but it's okay. The timing is usually around weeks or days. Okay, but if like 100 meter, how far actually from that particular surface and go to the ocean water, because we have current, so current at the oceans. That's the difference from river also has current, usually from the upstream into the downstream. Ocean, of course, it has current, but I think lake are much more constant. So any from downfall of the microplastic, I think will be very faster rather than current at the sea. Okay, but right now I'm not using the flotation because we found that flotations will trap microplastics at the glass wall there. So we are not getting 100% of microplastic from our sample. So we cut off this particular method, because the less method or the less method that you have, you will increase the chance of getting 100% of microplastic. I mean, like what's your thought? I mean, like, you have 100 in the sample, and then after you all this method, and then you just left around 10. So you miss around 90%. Okay, and then physical observations, and then the polymultiplication by FAR. Okay, this is data about the FTIR. So we usually the search score, because all the peak has been confirmed in the library. So anything that you found, the peak, they will match with the library. So the search score should be 0.8, should be the best one is 0.8, which means that 80% match the peak of PBT, PVDF, or PC, OPS, and everything. Okay, this is my project during that time. It's at Penang at Langkawi, because I have data for all Malaysia, right? So I just for this publication we just separate by islands. Okay, so we have see all this microplastic at the rocky shore, even at area of I think Penang, that area of this Balik Pulau, right? This Balik Pulau, and then this one also. No, this one. That's quite far from other people. And at Langkawi, Pantai Pasir Tengkorak, if I'm not mistaken, Pantai Pasir Tengkorak. I mean, it's quite far from the other people. So we still found the data of microplastic. Like I said before, that the connections between oceans can bring a pollutant from far, very far. Even if you do a beach cleanup, I used to have a beach cleanup at our area, Kuantan. You can found the bottle that is not from Malaysia at all. How do you know? You can see the label of the bottle. Sometimes from the Vietnam, sometimes from the China, sometimes from the Thailand. You might as well say that maybe some people bring that. Okay lah, we cannot discard that idea. But if you find many, actually, it's from that particular area. If something from like US or UK, of course lah, that one you can say that maybe from them, maybe, but maybe because ocean is connected between each other. Okay, system. Okay, I think this one Penang, Langkawi. This one is Malacca and Negeri Sembilan. This one, what is this? I think Langkawi. Yes, Langkawi. Okay, we found that all. We found that data, and instead, okay, we have some data like this one. Dominant is PVDF, PPVDF, something from the factory, and in fact that I used to have data about in fish for microplastic in fish because for heavy metal, I right now it's okay unless the mercury, heavy metals, microplastic in fish, microplastic in bivalve, and oyster, microplastic in the water, sediment, waters. I found that all of the samples has microplastic inside. So my hypothesis right now that all of that exposed to the environment, such as oceans, river, or aquatic water, has been contaminated by microplastic. Even we have found microplastic in the airborne area. You can have atmospheric microplastic. Okay, so you see that's hypothesis. You can find even if you Google right now, we have much more sample has been found. Okay, because in that pathway I used to say to you just now, I mean like contaminants will enter this particular bioindicator, and then we do some assessment, and then it can be sold to people. We can even export, can import this, right? And then the last, it will hit us lah. It will hit us as a human consumption because we need to eat. We need to eat. If some people ask me, oh, okay lah, so I don't want to eat fish. Okay, we found in crab, we found in vegetable, we found in water, of pipe water. We found that okay lah. That's why lots of country is pushing this one. At the Southeast Asia level, also policy of the plastic has been getting tighter and tighter. It cannot stop directly. Of course, for me, the the law and enforcement is the most confirm one. You can stop everything by law enforcement. Okay, right now, but I think because it affects the industry, I understand because it will affect the industry. So it we from like slowly try to digest this problem lah. Because right now you can see lots of mall, lots of supermarket not use plastic anymore, right? Even if they use, I think weekend is confirmed, but some like Lotus, they're not used to plastic anymore every day. Also, it's a good things, but we need to find a good solution also for not using plastic. Because some people ask, okay lah, we cannot use a plastic bottle. Okay, I'll change to uh, glass bottle. Okay, it's good. But practically, it's very heavy. Right now, it's very heavy. So that's why reuse or rethink is better for that particular things. Okay, and then, okay, this one about coral. I've said to everyone here that I'm also a diver. Okay, so I dive to get some samples. Of course, you need at Pahang. We need to apply for permit for this particular project. So we need from Pahang, it's Maldives Ballistic Pahang lah, to apply for this one. Okay, okay. At Kuantan, we have a coral dive site at Pulau Ula. So the site, it's not like Pulau Tioman. It's not like Pulau Tioman that's quite far. So you can find a blue waters there, which is the visibility must be very good. But we talk about at Pulau Ula, but just around not 1 kilometer, it's not 1 kilometer, just like 500 meter from the coastal, you can found that lots of uh, coral species like Acropora, Montipora, Porites, Tubidaria, what else? I forgot about that one. At that area, but the visibility is not so good lah. I think it's better to diving during the transitions of high tide and low tide when the water is stopped for a while. We call that air mati lah for divers or for fishermen knows about this one much better. Okay. So I took some of the sample, so we digest that and we find all the microplastic itself, which means that it's not exactly all the moving like fish or sessile bioorganism, but the a life form like coral. Coral is a life thing. It's not a plant. It's a coral life thing. Also, are exposed to this one. But of course, because they are exposed to the oceans, water from the birth. Okay, from their birth they are exposed, which means that it reflects the water around them, surrounding them is exposed to microplastic. Okay, so I share some data here. Okay, you see that uh, this is I think this one is Pulau Bahala. I think no, sorry. It's one of the at Ceruk Paluh area. It's one of the dive site. And another site is at the Pulau Ula lah. Right, Pulau Ula. Okay. Number one, Pulau Ulawan, Pulau Tu. Okay, the one is Sherbalo. Okay, you see, this one is quite a bit far. This one is just near to the coastal. Okay, so we found this particular microplastics, and we also compare them with the library of FTR. So we found a match. I think it's 0.85, 0.8, something like that. 0.9 also we get. Okay, so it match that. It means that they are the polymer of microplastic. It's confirmed there is the coral itself is not there is a microplastic inside. You might say that okay lah, coral we cannot eat coral, right? Okay, but the thing is that coral is a home. Coral is a home for fishes, for coral reef fishes that usually is linked to the web or chain, web food or food chain or food web. Okay, which means that if the fishes, the coral itself, the microplastic has been confirmed that uh, it decreasing the growth of the coral, and some of that I think will affect their stressor and their body change and their body growth and everything. Sorry, is there anyone comment something? No, right? Okay, sorry. Okay, so that's a microplastic that has been found. So it's confirmed. So when their growth are not so good, it cannot protect the protections to the. It cannot give the protections to the reef fishes. The small one. The small one will be eaten by medium one. The medium one be eaten by the predator or the high one, and then we will take. Usually we will take the medium or the highest, the large one, right, for our food. So it reflects. You don't. If the lowest one have no home, where will they go? So some of them, you can see from the news stated that you cannot find fish in this area anymore. You cannot find in the fish area anymore. So that's might be some causes of that, because we have lots of decreasing on coral reef, death of coral reef, or during the high temperature of the, maybe like from this one, if we have this high temperature of weather every day, so it will touch or will affect the high temperature for the ocean itself. So when particular coral exposed to high temperature for all the time, so it will have a coral bleaching. It will have a coral bleaching also. Coral bleaching, which means that it will not dead. Just the zooxanthellae. It's a coral reef is symbiosis. You have zooxanthellae. If they don't, the zooxanthellae organism that are not stay there, when it's very hot, the zooxanthellae either die or transfer to other area. The coral itself will bleach. It will dead for a while. For the color will be all white. That's the coral bleaching. That's the coral bleaching. Okay, but it will recover. Usually recover right now from our data and also with from Reef Check Malaysia, we found that the Pulau Tioman Island, the recovery much faster compared to other places lah. Even at national levels, Jabatan Perikanan Malaysia, DUF, Department of Fisheries Malaysia also has stated that some of islands need to close for a while because they are afraid of tourism activity that might as well give be the driver for this coral bleaching, because they know the coral bleaching will means that no home for the fishes and will bring to the food chain and food web that I said before. Okay. All right. Uh, next. Oh, it's already some 11 something. Almost 1 hour this month. Okay, I'll be fast one a bit. Okay, this is the project contaminants for system, which means that something, if something exposed from us, as a humans, we need to live, but we need to live sustainability with the environment also. Because if environment happen something, we also will be affected. Sooner or later, we will be affected. All right. Okay. So some of the industry or any coastal populations uh, will expose the oceans, the coastal area with some waste or some industrial waste. It will affected by the any start maybe from filter feeder at the coastal, and then start from the fishes. We have pelagic fishes, we have demersal fishes, and then coral as well. So everything, and then it goes to our our food. I talk about the context on ocean only, because we have found lots in the land also of the heavy metals, rare earth, and microplastic as well. Okay, so this anthropogenic oceanography means that I this one is like for you all. I mean, like for site officer and or any technical agency. So what we need here actually is a coordinations, continuity, and shared interpretation. I mean, like some of us knows about this. Some of us as know it's not reach that particular knowledge is not reach to some population. So that's why, as me as a researcher, I also go to field. I want to disseminate all the knowledge that I got to the all populations. But also when people knows about this one, so there will be maybe some coordination or something that will doing from his or her own self. Okay, but it just must be integrated, because like in Malaysia is not very big. I mean, like me in a marine or oceanography ecosystem. Usually, when during the conference or that involve oceans or marine science, we will find the researcher of each other, because Malaysia is not so big about this one. Uh, it's the thing. It's the same things like company like you all from hospital, some are maybe from university. If any one of us knows about some knowledge about this one, we will have coordinations or collaboration with each other, right? Okay. So that's the thing. I mean, like if we knows about this one, what must be done? Okay, it's not longer about what you know, because right now it is internet area. Everything is just on your in the peak of your tips only, right? It is about what you can do with what you know. So everyone knows about the knowledge. Maybe some of you might be just forward the knowledge, okay, but some act or that, and then some actually move somewhere for collaboration or for connections, for networking and everything. At least something must have been done, because we know sooner or later, if this thing has not been prevented, it will come to us. Just sooner or later, it will come to us. Right. Okay. So usually on the front line, we have some field officer, laboratory officer, technical agency as a central nervous central for a central system for detection and response. Because some of officer, they knows exactly, like me as a researcher, I know about the data management, sampling, blah blah blah. But who handle all the equipment and everything is the officer, assistant officer, of science officer. So I really need them. I really need them, because maintenance, uh, what else? They do some calibrations, everything is the officer. Because like me, well, I can only focus on one. Multiple, but not everything. Multiple, but not everything. So in any way of work, we really need each other. All the system, everyone is equally important. All right. And then that's why stronger collaboration is mainly required for us to have a baseline data, rent analysis, and deploy infrastructure. We know about the budget of Malaysia, right? We know about the budget of Malaysia. So the budget itself, if we have 10 office, the budget will be this into several office. So some office will find this buy this machine, some office will buy this machine. It's good if we have like a collaborations to how about use this particular machine, use particular machines. You are not competing each other. Because that's the source is one. It's a Malaysian budget, right? So I think that one is good because in Plains Malaysia, in Sabah, Sarawak, we are not very far from each other. Just need some coordination only. No worry at all about this one. Okay. So this is some pathway for interagency collaborations. So might be joint monitoring. So this one is because I have just received a project grant from Department of Fisheries Malaysia this year, that's January. So we do some joint monitoring about this one. I also ask for some laboratory collaborations because like UIA, we also have ICPMS, but and UF also or biosecurity also have ICPMS. So how can we like compete, not compete, complement each other and do that because the data should be a very protocol and then the QC must be very good. Okay. And then the data and reporting, of course, that is why the sampling and everything must be that it must be recorded, so or else you just go for fun only. It must be recorded, and then the data is a very powerful thing. The data can be changed into lots of things from lots of things. We can find the trend analysis and we can find do a predictions. We can do a modeling and then we find the solutions from that particular ones. And then last but not least is capacity building, which means that we try to have, like I said before, I have the knowledge about that particular things. So why must I say for myself? Why? How don't we go for cross-agency staff attachment? We do a joint workshop, and then student agency project, or maybe for us, one of our KPI research is academic research is publication. We can together about this one. The more you share, the more you get. It's my principle, so everything is in my knowledge. I can just transfer to everyone. All right. Okay. So the next leap forward will not come from a new piece of equipment, but it will come from stronger, seamless collaborations between university, laboratories, tech agencies, and like site officer, like in PPSM. You are in scientific part, right? Certain Malaysia. Okay. So this is what I hope. This is what I hope in the Malaysian context. Even like in Malaysia for universities, not every university has marine science. On my knowledge right now, like UITM, from USM, UKM, UM, UTM, I think it's Cairo, and then from us, IUM, and then UMT, and then UMS, also in UMS. I think Unimas, they changed to the freshwater, if I'm not mistaken. Freshwater and marine, if I'm not mistaken about this one. Okay. So that's why when we have collaborations each other, we will see the same face. We will see the same face. Just additional of new face and new face. The top one like the professor and the biggest name like from industry or from the officer itself. We know actually, we know. Okay. I think that's all. Actually, that's all from for today talk. Okay, that's all. So if you want to connect with me, you can just contact me directly through WhatsApp and everything, or you can find me in the LinkedIn. Uh, so just type Fuad Miskon. I think Fuad Miskon. I think the only one. I don't know. I don't know in Malaysia. Not yet found somewhere name same and my father. Okay, or you can email me at any time. Okay, anytime. Uh, I think it should be video actually about this one. This I take the picture from Pulau Perhentian, for Thailand because it's from the ocean floor, then it's going fly, swim. So the video actually is very, very interesting on this one. Okay, I think that's all from my side. It's also we have reached 12 o'clock. So, okay, Madam Oi, I finished my presentation. Thank you so much, everyone.
you so much, Prof, for the very accidents and comprehensive presentations and a very nice pictures that you show to us. I've never been into the sea before, so it's a
Let's
very good
go, madam.
experience. If I don't know how to swim also.
It's okay. We have life
Okay,
jacket. No worries.
okay. So, due to the time constraint, we will now directly to the Q&A sections. So, see, anyone got any question? Check in the text box and see. So, okay. So, actually, Prof, I got one question I would like to ask Prof regarding to the pollutions in the marines. Okay. For examples, like now for example, the Penang Islands, they got doing the bridge. I means the Penang Bridge.
Mm.
Did the sound pollution? Did you do any research about the sound pollution towards the marines' life?
For sound pollution, oh, about I'm only focused on physical and chemical contaminant right now. But I do not
Mm-mm.
do research some on sound pollution. But of course, when you talk about sound
Okay.
pollution, actually it matters. Uh, I think instead of bridge, we also have an issue at Tioman about the they want to have an airport there. So you know that airport and plane everything is quite, you know, the sound. So it will affect into the marine life as well. It has been confirmed by researcher, by lots of articles, so that it will affect marine life, even at coral itself, and then the current as well about this one. I do not have the research data on that one, but it has been confirmed worldwide about this, the effect of this sound pollution, madam. Mhm. I see there's some question
Okay, there
also.
is a one question in the chat box. Prof Hafiz here. Okay, if this weather hot longer than usual, adakah akan mempengaruhi keberadaan ikan kembung atau saiz kecil untuk ikan layaran datang nanti?
Oh yes. Okay. Actually, it has several sebab lah, several drivers for these fishes. Right now, some of them, one temperature also one a driver. Usually, temperature will one first thing first. Temperature will affect their migrations. So some fishes, they are very, if they are not that fast, they are very prone to slight change of temperature only. So if there is the change is getting higher from the slide, so they will, first one, they will then start to migrate to the cooler one, to the cooler area one. Actually, when you talk about this one, the tropical country, if the fishes are not adapt so much, they will start to move to the middle cool, and then Arctic is very cold, or Antarctic is very cold. So usually at the area of not on the Khatulistiwa line, right? But on the growth itself, or even at the cell area, yes, it has been found in the literature or in the research project that temperature also is one of the driver. Because why? Because when because like I said, that uh, fish, they live like a biological cage. They only live for certain salinity. They only for certain temperature. You cannot see this biological cage because ocean is very vast. So that's why you will see that these fishes is only stay at that level. This species of fish only stay at this level. But there are some species also can go high and down as they wish. Some of them is rare, which means that their body can adapt the salinity changes. So it's also the same with temperature. Some species can adapt with temperature faster. Some fishes cannot. So that's why you will see right now the size of fishes has more in decrease during for time to time. You can compare like 20 years before or 30 years before, people used to eat fishes like this size, right? And then right now, this size is like a very premium one. You only can has this size as standard size for this factor. It's one of the, it's not exact as one factor, but it is one of the factor. Uh, so which means that it's also will affect the ikan airan, a billfish that come to Malaysia. Billfish is migration fish, and when we talk about migration fish, it will come when two things: when the food is there for them to replenish the energy, or second, the condition of that area is good for their to release their eggs, so there are two things about that one. Eggs, larvae, and everything also very uh, not adapt much on the temperature because they need certain temperature to release. When the time is come, they will hatch from the egg when the time is come. So when the time is not like not so good, everything, some of them will hatch, but not completely should be their level. So I hope that one help in answering that.
Okay, another second question about the microplastic. Okay, apakah impact of this microplastic in the fish that can trigger any health issue when we consume the fish? Adakah any danger to our health or belum sampai tahap itu lagi? Ada study tak berkaitan dengan isu ini?
All right, okay. In the research area, lots of study has been doing this. Even myself right now, I'm doing for in the gut. I'm helping from the medical one to track microplastic from the cancer and non-cancer of the this one what I say I forgot, collateral area, colon is a one colon right now. We are going to see whether the connections between them. All right, but in all over the world intentionally it has been doing right now, but because when you talk about health, it needs lots of data and also longer one. We cannot like microplastic right now. I'm very sure that we have everyone actually here, hopefully not everyone has been consumed microplastic a bit, at least a bit, in our body. It might have in our body, maybe because we have seen the data of microplastic in blood, microplastic in placenta, in breast milk, and what else? In blood, that's one the issue of blood now, which be much problem. But the effect of that microplastic is still confirmed because it need to be long because you cannot have a direct effect of microplastic. Right now, you can see a lot of cases of cancer. So that one is the try to relate that with microplastic. Some of the research has been confirmed that, but still in debate whether that this data is still enough or not enough yet. Because it's like, because human health, right? You need a data of 10 years, you need data of 5 years, then you can confirm that. All right. And then, so, and then when you talk about health also, if it's like I said about heavy metal in fish or fishermen, it will trigger something. It will trigger some industry, it will trigger that one. So even at government level, before they do some statement of this one, need a very confirmation data, even from our ni lah, our local talents also, our local talents. Microplastic has been top popular in Malaysia starting from 2014, 2012 something. It has started. Internationally, it started long before that. So from that particular area, most of university have started on this one. And I've been there to microplastic seminar by Nahrim. And then there are some from the Ministry of Health also, but there are not much more comment from Ministry of Health during that time. So I was thinking maybe microplastic has just started at the Ministry of Health level also. So which means that we will see your question, Cik Hafiz, later, the solution of that later, because government level, they need to confirm everything. So at the fish level, has been confirmed that it can slow the growth also of the fish and the coral itself. It has been, but I'm not testing this yet. I've asked for grant for this one, but not yet have rezeki on that one. But I'm not testing yet. You can find from literature, research from other researcher, microplastic can impact the growth of some fishes. Microplastic can also growth of coral. They are also infected about them. Okay. So if you ask me your question about other study tak berkaitan isu ni, yes, we have lots of study. You can Google it. And then to confirm it will help issue, still in debating, but I think we are really near to that decisions, to that solution and as well. All right. Okay. I hope that helps.
Okay, thank you so much, Prof. Okay, since there's a time constraint, so there's a few questions that the Prof had prepared to us lah. So the first one is, so see anyone can answer. Do you think the ocean today is still a natural systems or already influenced by the human activities? Anyone can answer the question?
This question from me, right?
Yes, yes. Next
And
time, I
then what?
think I will need to prepare certain present for them who can answer the question.
Right. People always like something present.
Yeah. Anyone?
Semua jawab dalam hati, I think.
Yeah. Or can answer in the chat box also can. I just read to others. Not no response.
Repeat
Repeat
again.
again. Okay. Do
Yeah,
you
please.
think the ocean today is still a natural systems or already influenced by the human activities? Cik Muhammad Nur Hafiz?
Kena panggil.
Okay, her answer is near coastal area influence. Is it correct, Prof?
Yes, it's correct. Yes, correct.
Yes, it's correct. But there's no present. Okay.
Because maybe I add some input on that because human population usually at coastal area is a fact. Even at the ocean, the good thing about ocean is that it can replenish by itself. I mean, if we put some waste into that, they will. We talk about chemical pollutant. Chemical pollutant, they actually can replenish all the chemical pollutant. But things like physical pollutant, like microplastic I just share right now is a physical pollutant. So it will change from the plastic, microplastic, and then nanoplastic, and then even picoplastic. So it replenish, but it will be very long. Chemical pollutant usually it depends on the element. It will be quite low lah, quite low timing compared to physical pollutant. Yes, and then yes, ocean has already been affected by humanity. Yes, it also yes, because we have a very physical, chemical, soil pollution and everything. So we have lots of pollutant. So some of the answer is the coastal. Some of the answer yes, it has been affected, but it vary from pollutant to pollutant. All right.
Okay, another questions from the Prof. How do you think the pollutions behave in the ocean, isolated or interconnected? How do you think the pollution behave in the oceans, isolated or interconnected? Anyone can answer the question? Oh yeah, there's a
Then
answer interconnected. Correct, Prof?
yes. Oh
Yeah,
yes.
it's from Intan.
You have some present.
Okay. Then another question. If the ocean is always human influence, what should scientists focus on next? Anyone can answer? If the ocean is already human influence, what should scientists focus on next? If no, then we can get the answer from Prof. Solutions in
They make more coral.
make more coral.
Jaffe said.
Is it
It's
correct?
one of it's one of the answer also.
So
I need
maybe
to
Prof.
also give some input also. I think because I put in the question is scientists, which mean that if I ask about what should people do, it will very various of question answer because scientists, citizen, agency, government, even uh, local with coastal population, citizen. So everyone has their own things to do. But if you go directly, like make more coral, it's okay. Make more coral. Usually, researcher also doing that, and also NGO, NGO, NGO such as I think Reef Check. Even okay, company CSR also do this coral, artificial coral, because I've been uh, joined some artificial reef dumping into the oceans from one company at Kuantan area. Okay, some company do that. Government also do that. Usually under LKM and UF, they have their own artificial reef area, and agency like CIFDEC is also under UF. They are the one who design. Usually they are the one who design of this one. But lots of company has started to do this artificial reef because of. I'll give you example. Usually when you go for coastal area, yeah, you apply and then you have, you have your application has approved. So you need to do some suitability of an OCSR project. So usually for those that do some on the oceans, you need to do the best thing. One of the thing is make more coral by doing artificial reef dumping. Usually depends on the quantity. Some big company will dump the big one. It'll almost like 3 or 4 times, even with more. Okay, and then law enforcement, yes, law enforcement, but it needs from the top above. But for us area, like researcher, for even agency, even for standard, not who else? Standard company, and then for a citizen, we can bring this up. But usually, for if you go for the law, we need to very strict. Right now, the best one for this law will be Jabatan Perikanan Malaysia lah, because they have under bahagian of konservasi dan taman laut. And that is usually is the one. They are the one who do lots of thing about the conservation of thing. And then I see some message also, Madam Oi, about the yes. Oh, you already have asked your email address, right? I can give the
Yeah, yeah.
slide. No worries, no worries. I can give you the slide.
Okay. Thank you.
Oh yes,
Yeah.
I gave you right just now, right? You can give to others. No
Yes,
worry.
yes. Okay, okay. So I'll
Yeah.
email to haha. So
Uh-uh.
anyone that want the slide maybe can give the email address to me. I will email to.
Yes, educate. There's some message though. Shafi said government already did something such as did not chat about you because the boat paint they have TBT, usually have TBT or some chemical pollutant also, then will have some imposite issue to the marine life. That's the thing lah. Uh, and then educate our child early age on plastic pollution. Everything. Okay, this one is also good. We have lots of chat in the chat. Oh yes. Okay. Yeah, it's very congratulations for Kuala Lumpur boatman or boat operator. They did not use the paint anymore. The polluted item development. Because I also have some conversations with a company that repair ship or boat. She just said that there are some of the boat owner bring some paint to them lah. So they just need to paint. They don't know actually where's the origin of that particular thing. If I'm not mistaken, we have these conversations. Uh, Okay, educate a child at the early stage plastic. Yes, it's good, but we also have some child also like 7 to 10 or 7 to 9, 10 to 12. So they have different kind of level. Even at the secondary, they have a different kind of level. So we need to try to adapt to that level because they can consume lots of data for secondary lah. I mean compared to primary. Okay, all right.
Okay. Another question, last question, I think. I want to ask Prof. Regarding to the tourisms. Is it
Mm.
the tourism sectors need to do any efforts towards the tourists that coming to our countries to that means to the beach to reduce all the pollutions?
Okay, about this one, okay, there are two answers. The first one, we have been asking about this one before, but in Malaysia, some of ministry has a different policy from some of another ministry. For example, tourism is under Ministry of Tourism, right? Ministry of Tourism. When we talk about the ocean right now, Jabatan Perikanan Malaysia, DOF, is under Ministry of Agriculture and Food Sustainability, AFI. So there are two policy of ministry about this one. So when we want to go for sustainability, if I'm not mistaken, like tourism, they are very straightforward on the bring tourism and expose or advertise about our tourism and then manage it for our country. So the one you usually must do is the Ministry of Sustainability lah, that food sustainability or DOF lah, Jabatan Perikanan Malaysia. The one is the one who do that. We have been doing a questionnaire project about this one also, like last year. So we went from island to island, asking about the predator, asking about the tourists, about these sustainability things. There are also some input from them because there are some Jabatan Perikanan also. Jabatan Perikanan Malaysia also has a different TOR, term of reference compare. And island usually have NGO also, have NGO and then the dive operator. Sometimes they did the conservations by themselves, and then that's the thing because there are some of miscommunication or there are some lack of information about that one. But everyone knows actually, that this particular thing must be continuously done. So if there are some bureaucracy, maybe at government level there are some bureaucracy, but usually NGO or dive operator, because they are directly towards that, which means that dive operator, if you have broken or coral reef has been affected much by pollutant and they die, and after that they will be much more affected. So that's why sometimes they do by themselves because they don't have a bureaucracy. Even at Tioman have TDA, Tioman Development Authority. I'm not sure about Perhentian or Redang. Okay, or Redang. Okay, so that's the issue right now. There's some issue that need to be settled. But nevertheless, some of the one that are not have a bureaucracy much, they will do by themselves. But we need some coordination about that one. We need to make sure that everyone do the same method and a very good method. And I will see from my visit to all the islands, they have that particular things. There are some limitation, there are some challenge, but everyone like saying we must do this, we must do that, and then some of them actually has their hands on that one area, right? Yes, some tourists do not pollute the water. Yes, maybe. Yes, of course. Tourists really, but we need to learn. We need to have evidence on this one. Some of them, this one, like they say that tourism should give during for like Tioman, the ferry is almost 2 hours. The ferry almost 2 hours, and when I ride on the ferry, it's good to have a, a video, a documentary about how to conserve the oceans, how to conserve the coral, how to conserve the marine life itself. Because it's hours. And then sometimes just repeating the same video, I think it's very good to. So when they have arrived, some of the knowledge has already been there. You unconsciously you masukkan in their brain and mind. It's one of the things lah that can do. one other thing, or at the jetty or that area, one other thing. Okay. Mm-hmm. Yes, but this discipline, yes, sometimes it depends from country to country, and even for country itself, it depends on civilized or uncivilized. I mean, like some of them I naturally knows about this. Some of them just I don't care about this one. I want to spend money only. Some of them I don't know because I think Chapis is the one from a boat operator at tourist area, right? So you know better about this one. But of course, I very agree with that. All level should doing this thing using your own template or TOR, bureaucracy level or everything. Have one target, but you need some coordination. You need some coordination, or else you do this, you do this. It's just the same objective, the same thing, but you have your own method, you have your own method. So we need the coordinations. It's the same like ocean in Malaysia. In Indonesia, we have Kementerian Kelautan dan Perikanan, if I'm not mistaken. So you have one ministry to cover all the oceans. In Malaysia, we don't have a ministry exactly for cover oceans. Before this, we have NOD, but then I think political issue or maybe something, I'm not sure about this one. We have National Oceanography Directorate. Right now, do not have. And about oceans, some has been divided into DF, Jabatan Perikanan. You have, if I'm not mistaken, during my time as a lecturer before, when I started, mostly also have some ocean department. And then you have Jabatan Taman Laut, you have APMM, you have Police Marine. So it's quite here and there. It's okay here and there, but it needs coordination. You need coordination about this one. All right. I think it should be,
Okay.
that's the answer your question, madam?
Okay. Thank you so much, Prof. Okay. So since there's a time constraints, is it possible everyone open the cameras so we just take a photo sessions? Uh,
I need to stop this. Oh, wait. Okay. Oh, I just found out